All right, welcome to the at-home material science lab. So since we couldn't do the actual lab, what we're going to do is we're going to try and do the next best's a demo. Let's say it that way, so that you can see what's happening at home. So we have talked about phase changes. We talked about at the beginning of the year. You should have seen them in physical science when you were younger. You have a background in them. You know that how phase changes happen. Except now we're going to talk about alloys because they don't happen in the same way. In a regular phase change, this is a phase change graph, right? We know that there is a specific melting point, that one temperature that element will melt at. So this is a phase change graph for iron, and you have the phase change there at about 1500 degrees Celsius. That's when that metal is going to become liquid. Now, on the water, your melting point is 0 degrees Celsius, right? So that's when it happens. It's a little bit different for an alloy, okay? Take a look at this graph here. Tin, we know, melts at 232 degrees. Lead melts at 327 degrees Celsius. They're not the same. So what happens when you combine the mixture of the two? Well, here's an even bigger question. What mixture, right? So what we're going to do is we are going to set up a lab with all different mixtures of lead and tin, and we're going to heat them on a griddle to try and see how these objects melt. So the first thing that we needed to do was we created spots, okay? So there are 11 spots in total, and they are all made out of tin and lead and tin, but they have different amounts of each of them in there. So spot number 1 is all lead, okay? And you know lead, it looks a little bit dull and gray, and you can still tell it's a metal, it's just not one of your shiniest metals, right? Well, tin, on the other hand, is actually pretty, it's very light gray, and it has a lot of luster to it, so you can sort of see the difference between the two. So the first spot is all lead, no tin at all. So that's 50 grams there. Now, we have an idea of when that will melt because we know, again, that the melting point is 327 degrees for lead, okay? Now, spot number 2, we're going to keep a lot of lead in it, but we're going to add a little bit of tin. So 45 grams of lead, 5 grams of tin. Spot number 3, a little bit more tin, we'll do 10 grams. And so that means we're going to take down 40 grams of lead. If you notice, all of these spots are going to be 50 grams total in mass. It's just a matter of how much of each is in there. So spot number 6 is 25 grams lead, 25 grams tin. Okay, half and half. There you go. A little bit lower, we go down to spot number 9 is 10 grams of lead and 40 grams of tin. And then the very last one, number 11, is no lead and a mass of 50 grams for tin. And we know when that's going to melt. That's going to melt at 232 degrees Celsius. So what we're going to do is we are going to watch the video of last year's lab where each student was assigned a spot for the lab. So each student was in charge of watching one spot and just determining when it melted. Another student was in charge of recording the data, and still another student was in charge of recording the temperature at which they melted. So there you'll see a laser laser thermometer there recording what's happening. So let's go ahead and see how things are going.
Guys, who moved?
Did you get a number?
Can you see the arch there, guys? Try and keep them there so that it stays on the sheet pretty consistently. So move them back to that arch where they were. Don't move them all the way around.
Oh my God!
Okay. All right. So make sure you have room for you. Which one are you
Cooking
watching?
some metal pancakes.
What number are you watching?
He's 11.
Put some bacon in and put it in a pancake.
Or just move 10 over
That's where it's
2.
gonna
Remember 8 then.
be.
It's gonna work.
This is a measurement my piss work told me I filled
We
my
need to
drug
rearrange our positions.
test. It wasn't. The measurement my piss work told me I filled my drug test.
Mine's gonna melt last.
295 degrees.
Oh my god. Oh, we're like halfway there.
Put your laser pointer on the hot plate, see how fast that melts.
Wait, which one's the
Really?
Put your tongue on it.
How hot's this one?
Which one's the I'll put my tongue on it for 50. Dylan, you would put your tongue on it for $50.
290.
No, you would not.
So much
But
for
your tongue would be done.
Dude, you wouldn't taste anything for the rest of your life.
$50 really worth not tasting something? I know you like eating.
The tip of my tongue. Brody's 91.
91.
This one is
308.
It's only 91 degrees.
I'd like a frozen
You're
bowl
ahead.
this, bro.
314.
Your
Something's
office is at
smoking.
200. Mine's at 91.
I think it's just a hot plate.
No, your head was
Dude,
at
there's some
91.
Look,
No, I got temperature.
metal
You go
right
home.
there.
Hold on.
I'm scared.
low temperature. You need to remember touch you.
38.
Don't. It's already solidified.
Don't touch it.
99.
Yeah, but I bet you it's still hot.
98.9.
Oh my god, guys, the lead's beeping.
Ow!
Yours is melting.
Yeah, bro, that's definitely
Yours is melting.
Her shirt looked like someone's
We got one melt.
Oh my
Wait,
god.
what? Let me see.
Number 8.
Number 8.
Number 8 melted first?
Yeah.
Holy cow.
Was that not
Is that-
supposed to happen?
Oh my god, it's because it's an alley.
Oh my lord.
That one's melting too.
Dude, it was
Let's
six.
put them together, guys.
Number 5 is 2.
That's number 6.
I have a chin.
Okay, can you-
I have a
Or
chin.
don't cover it.
Whoa!
Mine's starting to stick.
what happened? What next?
6.
6.
4's about to come, bro. I feel it.
Guys, can you see? Do you see something called slush? Don't.
It's the little.
Do you like?
It looks like that one character from Fantastic
It's not
Four.
a complete liquid.
You wanna see
It's
a
not.
guy
You guys know what I'm talking about, right?
Yeah.
Yeah, okay.
Stick your finger in there.
mine's
Nothing.
9 started.
Why are you touching mine, Dylan? What the heck?
Which one's yours?
9.
Oh, look at that! You guys see that slush there for number
5.
number 5?
Number
9
5.
went.
We don't touch it.
Did number 5 just go? Stop. Do you see that black right there? Any ideas what that is?
Sharpie.
The Sharpie.
Good guess, but it's actually not.
Impurities.
Oxidation.
It's oxidation. Oxidation. So those guys, the metals, when they're hot, they're reacting to the oxygen in the air.
Yo, I can't remember which one was
So
mine.
the black is that oxidation.
Shattered.
Yo, was this
Okay.
me?
Yeah.
No, I did that.
That's number 4, right?
Yeah, it's like.
And
I
then,
poked it and it
which
shattered.
one is this? This is
Batman
number
sign,
9.
dude.
Look at
So
11.
number 4 went.
Oh my gosh.
Dude, it's a bubble.
37.
Now this guy's not gonna melt because he's not on the heating element, guy. Who? What is this one?
That one's mine. That's 7.
England.
I
7.
I moved it
Out
because
of the
those
way
were.
because they were getting in the thing.
Yeah.
Okay.
So I didn't want it to get mixed up with the other ones.
So 7 hasn't gone yet.
Somebody poke 11.
Poke 11.
Has any more went?
Oh, 7 just went.
7.
7 just went.
And it just went, didn't it? Did
Yeah.
you see it go? It just was like all of a sudden it was liquid.
Number 1 just did that one.
And Guardian Lovey.
3 is not gonna melt.
Got that mixed up.
Number 1 is gonna be the last one
All
I'm
of them are
calling
going at
it.
11
No,
degrees.
3 is.
Looks like a freaking talon, dude.
3 is definitely the last one.
If you put pressure, it just melts. At least mine did.
This one?
That's a perfect circle. No one touched that one.
Good left, sorry.
Try not to mix them up for me, please.
10.
Oh,
just-
10.
10 starting. Yep, 10's gone.
I'm
So
scared.
that's the slush right there, guys, where it's not quite solid, not quite liquid.
There's only 4 left.
Don't try not to get them out of order so I can put them
Oh,
back.
well, I think this is 6 right here. They are
That's
out of
5. That one's 5.
This is 5 and
This one's 6 and that one's 7.
Oh, yeah. This
this one's starting to get shiny.
7,
That's
5,
4.
6, I'm pretty sure. Really, Dylan? Really, Dylan?
What?
Really?
5 and 6 got mixed up.
Really?
Okay.
I said really.
they move like.
Really, guys.
We only have 4 more.
Ah, it's getting hot.
How long is this gonna take?
Guys, can you guys try and put them back into so I can pick them up when they cooled off?
Your arm tired yet, Trent? That's cool.
Uh-oh.
Did you just break it?
No, I didn't. I didn't do nothing.
You did break it, because what's happening to it?
It's breaking apart.
Crumbling.
Sorry.
Stop.
Who's 11?
Stop breaking it.
There goes 11.
Oh my god.
There goes 11.
11:39. Rest in peace.
He's so excited.
2319.
We have, this was 1, 2, 3, 4. This was 5.
Like it'll fit.
5 lead.
This is
right?
6, I
You're
think.
gonna touch that.
Then this
Yeah.
was 6.
Yeah, that was
Yeah.
6, then 5, and 7.
5, 7,
3.
8, 9, 10, and 11
Stop
lead, right?
touching mine.
3.
I'll
Does
play
it
And you can
about.
see-
look like a boat, yeah.
See how the oxidation on top?
It looks
3
like
is
a
just
boat
about
that has
gone.
See,
the top
3 is
almost cut
almost
off of it.
Oh my god.
Okay.
You're making a canoe?
Heck
All
yeah,
those
I
as a
am.
count. Pull the
Sorry,
cords.
that was cool.
It's getting hot.
Okay, let's go ahead.
3 went, by the way.
Oh my
Three
god.
went.
It's
Krabby
gone.
Patty.
Who's hungry?
It's either 1 or 2 left.
Flip it.
Let's go ahead, guys. And I'm gonna turn, let's turn it off and go ahead and have a seat. Do you see that slot?
No,
before you-
All right, so going back now, let's take a look at what we observed. So after those spots, as you can see, or as you heard, I should say, number 8 was the first spot to go. And then we went 6, 9, 7, 5, 4. What I want you to take a look at is what the compositions were. If you guessed that the 50-50 would go first, unfortunately you were wrong. Now the interesting thing about this was, like I said, number 8 went first, but actually number 7 really should have gone first, and we'll explain why in a little bit. But number 7 didn't, because it was actually it was pulled off the hot spot, so it didn't have a chance to melt. So it wasn't at the temperature that it needed to be. It wasn't as high as other ones. So it was like being, next to the fire instead of on the fire. As soon as we put it back, if you notice, it melted immediately. I snapped my fingers, it melted like that sort of thing happening. So what I want to look at is this. So what we actually see happening, remember the first one to melt was our spot number 8. So here's 0 grams tin, 50 grams tin here, 50 grams lead over here, sort of thing. So number 8 would be about right here, and the temperature was lower. It was actually lower than both melting points because neither 1 nor number 11 melted first, right? Then we had spot number 6, which would be about over here melt, and spot number 9. We have more and more heat added, and it sort of goes back and forth, except for number 7, because 7 did something. Really, we should have 7 down here too, until we get to our higher ones. And if you notice, spot number 1 and 2 actually never even melted. But what we end up with is actually a graph that looks something like this. So this is what happens when we have combinations of those pure substances melting. The graph looks a little bit different. So what we're going to do on our next is, after you're done with this lab, we're going to take a look and see what those graphs look like. Okay?